Hello ladies and gentlemen, this is Mr. Cunningham, and what I'm going to be showing you how to do today is how to predict the products of a chemical reaction. So your objective, the thing that you should be able to do by the end of this video, is be able to predict the products of a chemical reaction. Now this is kind of complicated. It has a few steps, but it's a logical process. It's going to require you to remember a few things, so please make sure you pay attention. So, how you predict the products of a chemical reaction is obviously first you have to get a chemical reaction. So we're going to start with this one right up here. Mg plus HCl goes to something. We don't know, right? That's the whole point. That's the point of this video, is to predict products of a chemical reaction. So what do? All of this stems back to a video that I made that is called Identifying Types of Chemical Reactions. So we talked about in that video that there are 5 types. There's a synthesis reaction, there's a single replacement reaction, there's a double replacement reaction, there's a decomposition, and there's a combustion. Now in order to predict products, you have to know those 5 types and know the characteristics of those five types of reactions. So if you don't remember how to do that, then what I want you to do real quick is go back and watch that video, which if you don't remember how to find it, it's going to be right here. Wait for it. There it is, right there. So click on that link right up there. Then come back. So now what we're going to do is the first thing we have to do to identify, or excuse me, to predict a type of chemical reaction is we have to know the type of reaction it is. Now, how you do that is you have to look at the reactants. On this side of the arrow is the reactants. And so what we're looking for is this is an element. How I know it's an element is because it's one thing by itself. Magnesium, that's an element. And here we have a compound. It's hydrogen and it's chlorine. 2 things together make a compound. So any reaction that has an element reacting with a compound is a reaction that is called a single replacement. So I'm just going to write SR out here as a reminder. Now in a single replacement reaction, what's going to happen is one element, this one, is going to kick out one of these elements. It's either going to be the hydrogen or it's going to be the chlorine. How you know that is by the charge that magnesium wants to be. So what you have to do is you have to look on your periodic table. You find Mg. It's on the left side. It's in column 2, and it wants to form a +2 charge. What that means is that magnesium is going to kick out the positively charged ion in this compound. And in this compound, it's hydrogen. Hydrogen is going to form a +1 charge in this compound, and in a compound, the first element is always the positive one. So, magnesium wants to form a +1 charge, or sorry, excuse me, a +2 charge, so it's going to kick out the positively charged ion. So what we're going to get over here is we're going to get magnesium with chlorine. And the hydrogen is going to be left by itself. Now, don't forget what we've learned. Whenever we write a compound, especially an ionic one, we have to crisscross the charges. So, magnesium wants to be a +2 charge. Chloride is a -1 charge. So when we crisscross those charges, this 2 is going to come down here. This 1 would come down here, but we don't write those. So that would be my formula for Mg, or for magnesium chloride, would be MgCl2. I have to do the same thing for hydrogen. Remember, there are some elements that are diatomic, meaning when they occur by themselves, there's a 2 behind them. Hydrogen is one of those, so you have to remember to put a 2. I've now predicted the products of this first chemical reaction. Let's move on to the next one. Now, what if you're given a word equation? Okay, we've talked about solving word equations. So the first thing that we have to do to predict, it says predict the products of zinc reacting with chlorine. Well, in order to predict those products, the first thing I have to do is I have to write it out like I have this one. So, zinc just says zinc right here. Well, that's one element, zinc. So I write that, Zn. And it reacts with chlorine. Well, that's Cl, right? But remember, chlorine is one of those diatomic elements. So I have to put a 2 here. Now that we've got it set up just like this, how we had this first one, what I now have to do is I have to determine, is it a single replacement, double replacement, synthesis, decomposition, or combustion? Well, if you'll notice here, this is an element, and this is an element. And whenever you have two elements reacting, that's always going to be something that's called a synthesis reaction. So, in a synthesis reaction, all that's going to happen is these two elements are going to come together and make a compound. So we're only going to have actually one product, and it's going to be zinc bonding with chlorine. However, remember, anytime you make a compound, you have to crisscross the charges. So you look on your periodic table, zinc's charge is +2, chlorine's is -1. So when I crisscross those charges, there's going to be a 2 out here. And I've now predicted the products of that reaction. Let's go to the next one. So, in this equation, we have a carbon and hydrogen compound. We've called this a hydrocarbon. And it's reacting with oxygen. Now, again, you have to know what the formulas kind of look like for each of the types of reactions we discussed. Is it a single replacement, double replacement, decomposition, combustion, or a synthesis? Well, in this case, and hopefully by watching that video, you learned that combustion reactions are always a carbon and hydrogen compound reacting with oxygen. So a light bulb should go off in your head and be like, hey, this is a combustion reaction. And in every combustion reaction, what are the products? That's right. There's CO2 and H2O, or water. So, no matter what this compound is, it could have been C4H10. That wouldn't matter. Our products would still be carbon dioxide and water because it's a hydrocarbon or a carbon and hydrogen compound reacting with oxygen, and it always is going to produce CO2 and H2O. Let's move on to 2 more. All right, these next 2 reactions we're going to look at is we have sodium hydroxide, or NaOH, reacting with AlNO3, or what's called aluminum nitrate. Now, again, in order to predict the products of a reaction, we first have to identify the type. Again, there's those 5 types. This one has a compound. How I know this is a compound is because there's more than one element in it. There's sodium, oxygen, and hydrogen. And we have it reacting with another compound, which is aluminum, and then the nitrate anion. So, in identifying types of chemical reactions, we learned that this type of reaction is called a double replacement. And in a double replacement, what you have is kind of a flip-flopping of partners. Kind of like if you were dancing. You know, and if you wanted to dance with someone else, then you would go up, ask them to dance, and then you might like flip-flop partners. So, the same thing is going to happen here. Now, you might say, sodium is going to go and switch places with one of these elements or ions. Is it going to kick out the aluminum and go with the nitrate? Or is it going to kick out the nitrate and go with the aluminum? Well, how you determine that is based upon the charges inside the ions and inside the compounds. Sodium always wants to form a +1 charge. Aluminum always wants to form a +3 charge. Sodium is going to kick out the charged particle that is the same charge that it is. So in other words, sodium is going to kick out aluminum. Kind of like in dancing. If there was a girl that I wanted to go dance with, I wouldn't go and tell the girl to leave so I could dance with another guy. I would go, ask the guy to leave, I'd kick out the guy, I'm a guy, I kick out the guy, and then I can dance with the girl. Same thing happening here. Sodium is positively charged, so it's going to come in, kick out the other positively charged ion, and create NaNO3. Then the same thing's going to happen with my hydroxide. So aluminum just got kicked out, so it's by itself. So now this hydroxide is going to pair up with this aluminum. So you notice how they're kind of flip-flopping partners, and So we're going to have aluminum going with hydroxide. Now, don't forget, remember, anytime we make a new compound, we have to crisscross the charges. So, for my sodium, it has a +1 charge. I can look that up on my periodic table. Nitrate has a -1 charge. Well, when I crisscross those charges, they're both 1. So I actually don't have to put any subscripts on these. On my aluminum hydroxide, however, that's different. Aluminum forms a +3 charge. Hydroxide has a -1 charge. So what I need to do is I need to crisscross those charges, which means I need to put this 3 down here. Now, when I do that, don't forget, you're putting a 3 outside of a polyatomic ion, which means it needs parentheses. And now I've predicted the products of this reaction. This last one is a little more difficult. So all of these are what we would call kind of like formulas, I guess, for different decomposition reactions. Now, here's how I know they're decomposition reactions. Notice how there's only one reactant. Remember, reactants are the things that appear on the left side of the arrow. In this reaction, there's only one reactant in each one. Now, you'll also notice that there's different products for each one. And in these cases, an M just stands for a metal. So, for instance, this could be something like, let's say, calcium hydroxide. This one, let's say that this one is magnesium carbonate. And let's say that this one is sodium chlorate. Again, all this M stands for is some metal. It could be any one. This one could have been beryllium, or it could have been barium. Any of those are possible. So anytime you see a metal with a hydroxide, it's always going to follow this formula. Meaning, it's always going to break apart into the metal oxide. So again, you have to look, and these are things you're going to have to memorize. The metal hydroxide is going to break apart into the metal oxide. So what is the metal? Well, that's the metal, which means calcium oxide is going to be formed. Don't forget, you have to crisscross your charges. Because they're both +2 and -2, those charges are going to cancel out. And it will always be water. There's my products. Next thing we're going to look at is the decomposition of what's called a metal carbonate. Now again, this could be any metal. It could be calcium carbonate, sodium carbonate, any of those. But it's always going to follow this pattern. It'll always form a metal oxide, just like in the last one, except now we're going to form CO2 as well. So, because my metal is magnesium, that means this is going to decompose into the metal oxide. Notice how my metal was magnesium, so I put my metal from my reactant side right here. But don't forget, you have to crisscross your charges. However, they're both +2 and -2 again, which means those are going to cancel each other out, which means this is the correct formula, plus CO2. And I've predicted the products of the decomposition of a metal carbonate. Last one for this video. Now we have a metal chlorate decomposing. So I just plugged in any random metal. I decided to put sodium. Well, if you'll notice, metal chlorates decompose into the metal chloride and oxygen. Well, what you'd have to recognize is, oh, I only have one reactant. That means it's a decomposition. And you're going to have to notice that, oh, this is a chlorate decomposition. Again, this is chlorate. So it's going to decompose, and you need to remember that it decomposes into the metal chloride and oxygen. Well, in this case, what is the metal? Well, the metal is sodium. So it's going to form the metal chloride, which would be sodium chloride and oxygen. Don't forget to crisscross your charges though. Sodium is +1, chlorine is -1, or chloride, excuse me. So when we crisscross those charges, they're both 1, so we don't need to write any subscripts. Now, you might be wondering, what if it's not one of those special cases? What if it's just a decomposition reaction that doesn't have a chlorate, a carbonate, or a hydroxide? Well, if that's the case, how you'll know, first of all, that it's a decomposition is because there's just one reactant. There's one thing on the left side of the arrow. All that that's going to do is it's going to break apart. Well, in this compound we have potassium and we have chlorine, so I'm just going to split them up. But don't forget, if you have an element in there that's diatomic, you need to make sure that you make it diatomic and put the 2 when you split it up. So, in review, remember, in order to predict the products of a chemical reaction, the first thing you have to be able to do is identify the type of reaction. Is it a synthesis, single replacement, double replacement, decomposition, or a combustion? Then, after you've identified that, you then use those to predict the products of the next reaction. For single replacements, one of the elements is going to kick out the other, just like in this reaction. Magnesium kicked out the hydrogen because the hydrogen was positively charged and magnesium wants to be positively charged. Then, in this synthesis reaction, how I knew it was a synthesis is because they're just 2 elements and you're just going to push those together and crisscross the charges. Then, for our combustion, the products of a combustion reaction are always carbon dioxide and water. For our double replacements, the positively charged cation is going to kick out the positively charged cation of the other one. And how you know it's a double replacement is because it is 2 compounds. Then the carbonates, the hydroxides, and the chlorates are all going to decompose in different ways, and these are kind of some formulas that you need to memorize. So, hopefully you found this video helpful, and again, please ask me if you have any questions.